evaluation test for tablets. Okay, then the next session is the tablet coating. That is actually a finishing process for tablets. Okay, even though most of the tablets are coated tablets, there are particular reason for coating a tablet. Okay, so sugar coating is the simplest method of coating. Okay, and you have film coating, you have special type of coating like entry coating or some polymer based coating, etc. So the reason of the tablet coating can be different. That can be range from the change in the appearance of the tablet. It has to be identified specific to particular manufacturing or dispensing patient, and for the ease of use by the patient. If he is having number of tablets with his hand, okay, then it's create a particular type of brand imaging. Okay, then it is done to eliminate the free from taste. Then some highway it has to be done to mask the taste of the unpleasant drugs, especially for example paracetamol tablet. And the most common method of taste masking coating is sugar coating. Then odor, sometimes odor has to be masked. Okay, so it can be protected from environmental conditions. Okay, or sometimes improve the drug release characteristics. Sometimes it may give an extended release or sustained release or delayed release, etc. are particular reasons, okay, for coating sometimes. So the critical element for tablet coating are the tablet properties, that is a tablet bed. Then you have a coating apparatuses like coating equipments, coating parameters, facilities, and other ancillary equipments. Okay, sometimes because of the number of tablet is a huge load, then automation are sometimes done for coating. Okay, so these are the consideration has to be made for hardness, friability, the tablet core shape, whether it is round, oblong, or convex, concave, oblong, etc. So particular type of coating equipment has to be designed. Okay, then coating process, we will see the equipments. Okay, so there are number of equipments nowadays, from conventional to advanced one. So equipments are broadly divided into three types, that is standard or conventional coating pans, then perforated coating pans, and the highly sophisticated FB coater, that is fluidized bed air suspension coaters. So this is a picture of standard conventional coating pan. It is been made up of the steel and the current application of heat and air has given through inlet and outlet. Okay, and it is particularly made possible by a particular by rotation at a specific RPM. Okay, and the coating solution is either applied through pipe or spraying method. Okay, then this is an advanced method. And you have immersion systems where the air and the sprayer is immersed in the pan itself. Okay, from the figure you can see. So you have immersion system, it is a swab and immersion tube based and swab based systems for tablet bed. So the spray nozzle are and heated air are also within the pan itself. Okay, So these are the various type of perforated pan systems available in the market, like axillary cotar, high cotar, triacotar and galt cotar system. So this is the principle. So coating is done by concurrent application of the coating solution with air and hot that is hot air, and the RPM is set at some fixed speed. Okay, and these are the schematic representation. Okay, so the now system, now the industries prefer mostly the fluidized bed technology for coating, because the attritional effect are less in particularly with these systems. Okay, so one such of booster system is an example. This is a fluidized, where you have the tablet bed is been suspended in the air, exhausted air through the inlet air, and an atomizing system is the sprayer, which is applying the fine coating solution to the drop tablet which has been dropping down. Okay, so this is a Wurster column system used as FBD. Okay, so you have different pressurized systems as also available. Okay, so just go through the figures and description. Okay, so the coating parameters are the spray gun position, the effect of the pan load, air volume, temperature. These are very important parameters which influence the coating efficiency of the tablet. Okay, then coating composition, that is the composition of the coating solution is very important. It has to be dried quickly. Then we will see the types of coating. Conventionally you have three types of coating, that is filling, that is a sugar coating, film coating and entry coating. Okay, so this is how it is classified: sugar coating, film coating, conventional film coating using polymers, and entry coating using particular type of polymers, entry coating polymers. Okay, so sugar coating being the conventional method to mask the bitter taste of the tablet. You have a sugar solution as the coating solution, that is 66.6% sucrose, along with some opacifying agents and colorants are also there. So sugar coating is done with the same conventional pan which is already been shown, and it is broadly divided into multi-step process. So it is divided to sealing first, then subcoating, syruping or smoothing step, finishing, polishing, etc. So all these steps has got different operation procedures, like the particular RPM, jogging steps, then the air supply sometimes open or closed, etc. So has to get the dried subsequent coat over the same core tablet. So you have initially a compressed core of tablet, over which you make it waterproof by using some sealant like CAT and Zane, etc. Okay, then you are applying some subcoating, that is a syrupy solution over there, with followed by smoothing to get the even initial coat. Then you have adding it the coloring solution. Subsequent 2 or 3 steps you will apply the color, then finally polishing. So it's a very multitask procedure to get the sugar coated tablet. Requires skill as well as the competency to operate the machine. Then you have the various steps. Just to go through the various individual procedures. Okay, so seal coating, sealing, the affecting sealant being the shellac and Zane. Okay, then you have subcoats. The RPM is also very important. It's jogging speed means sometimes the speed has to be lowered, to run it for some prolonged period of time, overnight sometimes. Okay, that is done to make it the complete dry. Then coloring, smoothening, followed by last finishing by glossy syrup. Okay, heavy syruping. So this is very important, the stages in the sugar coating. You just go through the various steps. Okay, so finally you will get a sugar coated tablet. Then sometimes conventionally most of the tablets are film coated. Okay, so film means some particular type of polymers which is applied as a thin layer of coat of polymer deposited over the tablet. Okay, so commonly used materials for film coating includes polymers, that is also called as a film formers. Then you have plasticizers, which gives the elasticity to the polymer. Or sometimes it may be very brittle if it is the plasticizer amount is less means. Then you have coloring and opacification agents to make it non-transparent. Solvent also used. Sometimes the organoleptic compounds like flavor sweetening agents etc can also be added. So the most commonly all these properties are ideal for a material to be used as a film former. So most should have a high viscosity. Okay, so you can classify the film formers or the polymers into two types, that is non-enteric polymers and enteric polymers. So non-enteric polymers are most commonly used are HPMC, hydroxy propyl cellulose, then methyl hydroxy ethyl cellulose. All are these are the derivatives of the cellulose, semi-synthetic derivatives. Then you have ethyl cellulose, which is commonly called as EC. So then you have HPC, that is hydroxy propyl cellulose. PVP, polyvinyl pyrrolidone, commonly known as povidone, series by K15, K30, K16, K90 etc. So all these polymers have different solubility, like water solubility. Sometimes some are water insoluble, organic solubility etc, or sometimes soluble at body temperature or above body temperature etc etc. So you just go through all the material. Then sodium carboxymethyl cellulose, sodium CMC, is very available in different grades also, low, medium, high grades. Then you have acrylate polymers like Eutragit, which is very synthetic in nature and highly cost, and especially dissolved in acidic media also. Okay, then you have enteric polymers, which is a special type of polymer which is used to coat the tablets, where it is not released in the stomach but it get released in the intestine because of the alkaline solubility of the particular type of the polymer over it. Okay, so these enteric polymers or entry coating are specifically used to protect drugs from acidic digestion or acidic liable conditions. Then also used to prevent from particular diseases like nausea and distresses. Okay, and if the drug has to be given to the intestine means you have to make it entry coated. Okay, so through entry coating you will make the tablet susceptible to not resistant to the acidic pH in the stomach, but it will get permeability and susceptibility to the intestinal fluid. Okay, so such a kind of polymers include a cap, that is called cellulose acetate phthalate. Then some acrylate polymers like Eutragit L, that is soluble at pH 6, and Eutragit S, okay, that is soluble at pH 7. Then hydroxy propyl methyl cellulose phthalate, which is also available in HPMC 55, HPCP 50, 55S etc. Okay, Then you have also got a PV, polyvinyl acetate phthalate. So all the acrylate polymers and phthalate polymers are entry coating materials, along which with you need to have plasticizers like PEG, propylene glycol, glycerin, polysorbate, and castor oil. An opacifying agent most common used is titanium dioxide. You can also use aluminum hydroxide, talc, aluminum silicate, magnesium carbonate. Then solvents should be easily water soluble and also should be easily dryable. Okay, so these are the various defects of tablet coating. So most common problem is called blistering. Blistering is like bubble like structures which has been seen on coated tablet, and it is a local detachment of the film from the tablet coat forming the blister. Okay, so the reason is entrapment of gas or water over the film due to overheating, or if the spraying is not proper. Okay, so the causes, then you have chipping similar to the chip or detunted coated tablet, usually at the edges of the tablet. So also because of the decrease in the fluid air, or the speed of the drum is not proper. Okay, and that can also be corrected by increasing the hardness of the film by increasing the molecular weight or choosing a polymer having high viscosity. Then cratering means it is a defect of a film coating whereby volcanic lake crater appearance is exposed to the tablet, and that is usually due to insufficient drying or higher rate of coating solution, that all can be optimized to get the better coated tablet. The sticking and picking also due to improper drying or the improper rate of application of coating solution. So all this is very has to be optimized, otherwise it will lead to the sticking picking problems. Then pitting is the defect where the pit occurs on the surface of the tablet core without any visible disruption of film of coating. Okay, the temperature of the tablet core is different from the melting point of the material used in the tablet coating. Okay, so that is also improper drying condition, so that also has to be made optimized. Okay, then bloom or hazing or dull film appearance, this is the defect where coating becomes dull immediately or after prolonged storage at a high temperature. This is due to the collection of the surface of the low molecular weight ingredients included in the coating formulation, and most probably because of the plasticizer amount is not correct means. Okay, so the correct amount of the plasticizer has to be either in the coating solution, okay, or the especially using cellulosic polymers. Okay, so the also the appropriate drying temperature should be there, or drying time has to be given. Then blushing, it is a defect or the best described as whitish specks or haziness of the tablet film. Okay, and it is especially seen with cellulosic polymers. Okay, and you can use sorbitol in the formulation, so the gelation temperature has to decrease. Okay, and also the coating temperature should be proper. Okay, then color variation, which is already been seen as the mottling. Okay, that is a defect involve the variation in the color. This is because of the selection of the color, which may be either not water soluble or sometimes water soluble. So the mixing has to be proper. Then orange peel or roughness over the tablet, it is a surface or defect resulting the film is roughly or non-glossily finished over the tablet, and that is because of the rapid drying or high solution viscosity or indiscriminate use of the super disintegrant, etc. So all of that has to be optimized. Okay, then cracking sometimes seen because of the high if the high rotation of the machine. Okay, use of high molecular weight polymers also if it is not blended properly. Okay, then bridging or filling, it is seen with the bridging has been a bisect or monogram is obscured during the drying of the film may shrink pull away from the corners of the intergelation in filling of the. So it is a common in bridging and filling because tablet coating is a multi-step process, so it has to be made in isolation. Okay, so the proper or inadequate polymer concentration and plasticizer should be there. Okay, or the flow rate has to be reduced.